Well, welcome everybody to Hydroterra's latest webinar. Today we're joined by Louisa Rochford, Senior Research Fellow from the University of Queensland. And she's going to be talking to us about enhancing groundwater management by improving understanding of consumptive use, an example of a collaborative approach. What does all that mean? Well, Louisa did a PhD in this, and it's all about looking at an area that groundwater is very important in, and in particular, focusing in on how we get some of those important metrics to inform management in those areas. So it's really interesting. It's an area that Hydroterra has done a lot of work in as well up in the Surat Basin. So should be a good topic. Before we get started, I would like to begin by acknowledging that we conduct our work across this great land, and for that privilege, we would like to thank the traditional owners. Hydroterra respectfully acknowledges the Boon Wurrung people of the Kulin Nation, where we are located today, and we pay our respects to their elders, past, present, and emerging. There's a picture of our presenters. A little bit about our presenter today. So Louisa started as a geologist and then did some more studies and became a hydrogeologist. She has more than 20 years of experience. She has had a diverse career working in research, consulting and government. Louisa's main area of expertise include groundwater resource management, hydrogeological investigations and impact assessment. She has worked across a range of sectors including mining, energy, transport and agriculture, and her experience includes leading complex groundwater and surface water investigations for project approvals, operations and compliance, and developing water resource legislation and policy. Louisa is currently working as a Senior Research Fellow at the Centre for Water in the Minerals Industry at the University of Queensland. The role involves leading the hydrogeological research, training and consultancy services that the Centre provides to the minerals industry in Australia and globally, and working with a team of water management specialists to contribute to a range of interdisciplinary projects. That was a very long sentence. Louisa is currently leading research projects for the Australian Coal Industry Research Program, ACARP, and for mining companies around the world. She recently worked with the Australian National University, developing draft guidelines for groundwater monitoring in Australia. So I feel very lucky to have Louisa here to share some of her knowledge today, and it's great to see so many people here today as well. Before we get started, we love your questions. Please use the Q&A button at the top of the screen and I will read out those questions to Louisa at the end of the session. And thank you also for those early bird questions that have been sent through before today. Why does Hydroterra do these webinars? Well, we enjoy them. We like sharing knowledge. We like to facilitate such things, and we like to take a leadership position in industry. Thank you for all your positive feedback about the webinars as well. We really appreciate that. So without further ado, I would like to hand over to Louisa.
Thanks, Richard. So we might go to the next slide. Thanks for having me on today, Richard. You've already spoken a little bit about my background. So yeah, I work in for UQ, but I live in Sydney, and I've got a couple of kids. They're actually 5 and 8 now, so I need to update that. Yes, I'm a hydrogeologist, and you know, I've had a bit of a varied career path. So I started off as a contaminated land consultant and worked there for 4 years. Then I worked at the Environmental Defender's Office, which was a bit of an experience, and then worked for the Queensland Government in water planning. Then as a hydrogeology consultant for what used to be Parsons Brinckerhoff and is now WSP. Then I did my PhD at UQ. So I did my PhD as a bit of an older student, I suppose. So that was a really fantastic experience. And I'm going to be talking today about the study that I worked on for my PhD. So yeah, move on to the next one, Richard. And I just wanted to talk a little bit about the centre that I work for. So I work for the Centre for Water in the Minerals Industry. We're part of the Sustainable Minerals Institute at UQ. And so our aim is to promote the sustainable management of water in the mining and energy sectors. So our team is really multidisciplinary. And so one of our, I guess, key contributions is that we can bring that sort of interdisciplinary expertise to different research problems. We've also got PhD, masters and honours students that we work with, and we've got a number of online professional development courses as well. So if you're interested in learning about water in mining, you should definitely check those out. All right, on to the next one. So today I'm just going to talk a little bit about why understanding groundwater extraction for consumptive use is important. And then I'll talk about the case study area where I did my PhD, which is the Surat Cumulative Management Area in Queensland. And then I'll talk about the methods that are typically used to assess unmetered groundwater extraction, and then go through the approach that I took in my PhD, which was to meter a representative subset of bores and then use the data from that metering program to upscale and be able to predict groundwater at unmetered bores. And then at the end, I'll just talk about some of the limitations with the study and how a similar approach could be used in other areas. All right, on to the next one. So I'll just give a quick overview of the program to start, and then I'll go into a little bit of background. So in the Surat Cumulative Management Area, there's more than 18,000 bores that are used for stock and domestic purposes, but less than 1% of those are metered. So the program for my PhD involved metering a representative subset of those bores. So we metered 54 bores over a 6-year period, and then we use that data to develop a statistical model to predict groundwater extraction at unmetered bores. So the program is a really good example of collaboration between industry, government, the university, and also the community. So the program was initially funded by the coal seam gas industry, and then it was funded by the Queensland government. So yeah, it's a really good example of how, you know, different organisations can collaborate. It was a really unique project in a very remote part of the country. And the data that was collected it's quite a rare data set. So these types of bores are not usually metered. And so the data that we collected, is quite unique. And we'll talk a little bit about how a similar approach could be used in other parts of the world. All right, on to the next one. Why do we need to understand how much groundwater is extracted for consumptive use? So there's two main uses of that data. One of them is to be able to sustainably manage our groundwater resources, and I'll talk about that a little bit more. And the other use of this type of data is for impact assessment, and I'll talk a little bit more about that as well. So when we're talking about consumptive uses of groundwater, what are we talking about? So in parts of the country where there's not a lot of rainfall and there's not a lot of surface water, towns often use groundwater to supply town water. Irrigation is a big user of groundwater. Mining is also another groundwater user. So you dig a mine pit. If you're digging in an area where you're intersecting an aquifer, that groundwater is pouring into the pit, and then you have to dewater your mine. So mining is a take of groundwater. Coal seam gas also, to depressurize the coal seams and release the gas, they have to pump groundwater out of the aquifers. So that's another groundwater user. Feedlots, and then also water for grazing livestock and for domestic purposes. And if you press the down arrow, Richard, a little animation. Yeah, so this is what the study focused on. It was looking at what we call stock and domestic use, or in some jurisdictions, we refer to that as basic landholder rights. So if you go to the next slide, Richard. Yeah, so stock and domestic bores, they're not usually licensed or metered. Usually a works approval is required though. So if you want to drill a bore on your property to take water to supply grazing livestock, you'd need to put an application in to government to get approval to drill that bore. So the uses that are authorised are things like drinking water for grazing livestock. That's probably the biggest use. Also potable supply in the house. You can fill a swimming pool, you can water your garden, you can spray weeds around your cultivation areas. And in Queensland, these bores can also be used for dust suppression, where you've got coal seam gas activities going on. You can't irrigate your crops with the water from these bores. You can't use them for intensive livestock operations like feedlots. Can't use them for any commercial or industrial uses either. So that just gives you a bit of an idea of what these bores are used for. So here's a few photos just to give you an idea of what I'm talking about. So on the left here, we've got a bore that the pump is fueled by diesel. And then on the right, that bore there is an electric bore. You can see the electric lines up the top there. So we'll go on to the next one. On the left there, we've got a solar bore. So that's a bore where the pump is powered by a solar panel. So the pump only runs during the day. And then on the right there, we've got an artesian bore. So an artesian bore is a bore that taps an aquifer where the groundwater is under pressure, and the groundwater will rise above the surface naturally. And so those bores are capped to prevent the water just pouring out on its own. And so to extract the water out of that bore, you basically just open the bore and the water will flow. So the little solar panel there on the right is actually to power the meter. So that's the logger box on the meter that we had on that bore. All right, on to the next one. Okay, so we talked about one of the reasons that you might want to understand how much groundwater is being extracted is for sustainable groundwater resource management. And you can see this map here shows different areas in Australia where the state governments are managing water resources, so either surface water or groundwater resources. So what the state governments are responsible for is sharing water between users and the environment. And for groundwater, it's at the groundwater basin scale. And so what they're trying to do is prevent depletion of the groundwater resources. So, maintaining water for future generations. Also making sure that groundwater-dependent ecosystems have the groundwater that they need to continue to survive, and also to provide water for cultural purposes. So the availability of water in these groundwater systems and the rules for how the water is shared between users and the environment are included in legislative documents known as water plans or water resource plans. So under these plans, the larger groundwater users will typically be issued a volumetric entitlement. So that could be a water license that's attached to land, or it could be a tradable entitlement that you can buy and sell on the water market. And smaller users, like stock and domestic users, are usually permitted to take water without the need for an entitlement. Okay, we'll go to the next one.
Just before we
Oh,
do,
yeah.
so what happens when you're cutting across state boundaries?
Mm,
How do you
yep,
manage that?
that's a really good question. So you can see from the map that a lot of the all of the plant areas just stop at the state boundaries. But of course, groundwater systems and surface water systems don't stop when there's a state boundary. What often happens is, so for example, with the Border Rivers system, which is across Queensland and New South Wales, in that system, the two state governments collaborate to share the water resources. Another example is the Murray-Darling Basin, which cuts across 4 states. And you've got the Commonwealth Murray-Darling Basin Authority that developed the Basin Plan, and the purpose of that plan is to get agreement on how the water is shared between those 4 states. So yeah, it can become really complicated, Richard, and it can become a bit controversial between the states.
Do they have integrated models or?
Um, I think they do, yes. I believe for the Border Rivers system they do. I'm not sure which state is responsible for that. But yeah, I believe with the Murray-Darling Basin, they would as well. But yeah, I'm not across that. So
Yeah, I'm
yeah, I'm
not
a
sure if they do
little
for
bit out of
ground.
touch.
I think
Somebody
they
else on the call might know.
I
Yeah,
think they have it for surface water. I'm not so sure about groundwater in the Murray-Darling Basin.
yeah.
All right, better move on.
Okay, so yeah, if you're trying to sustainably manage a groundwater resource, you need to have an understanding of the groundwater system. So you know what type of aquifer you've got, whether you've got a fractured rock system or a porous system, the geometry of that system, and the hydraulic properties. And then you need to understand the water balance as well. So how much water is recharging your groundwater system? What discharges do you have from that system? And that includes groundwater extracted for consumptive use. And I think if you press the down arrow there, I've got a little, there we go, there's our groundwater abstractions coming out of our groundwater system. And you also need to understand any water dependent ecosystems that you're trying to protect through that water plan. I'll go to the next one. So numerical groundwater flow modelling is used for your more productive aquifer systems to manage the resource sustainably. So a groundwater flow model simulates the groundwater system and allows you to assess the availability of groundwater and how that might vary over the long term. And then once you've got your numerical model and it's nicely calibrated to your real monitoring data, you can then use the model to assess different scenarios of groundwater extraction. So you might want to have a look at how much groundwater can sustainably be allocated, what locations of bores you could install without affecting groundwater dependent ecosystems. So you can use that model to look at lots of different scenarios of water management. And so one of the inputs into those models is groundwater extraction for consumptive use. And just to note here, bit of a plug for Richard here, your numerical models are only as good as the data that goes into them. So Richard, I don't know if you want to comment on that. I mean, if you don't have any monitoring data, your model's not going to be much good.
Thanks for the plug, Louisa. So up in Queensland, we have been involved with Origin Energy on the monitoring of the Surat Basin, which goes in ultimately to the Office of Groundwater Impacts Assessments models, and they do display the data. And that integrated system is world class. It's a really good example. I think you might have some slides from that later. But yeah,
Yeah.
so we do produce those automated monitoring systems. But enough of that plug. Thanks, Louisa. We'll move on.
Okay, so how can we estimate groundwater extraction for consumptive use? It's one of the inputs into your models. One of the things you need to understand your water balance. How can we estimate it? So larger groundwater users are typically metered. So, for example, irrigation bores or town water supply bores. But smaller groundwater users, like stock and domestic users, are not usually metered. And this is because metering is an expensive exercise, but it's also, logistically quite complex, like all the maintenance around these meters, reading of the meters. It's quite a big exercise to meter these bores. So for these unmetered groundwater users, extraction is estimated using other methods. And depending on where you are and what data are available will drive what estimation method you're using. So if these bores have a license, you might just estimate that the extraction is the volume on the license. If you're in a region where you think, oh well, we're getting a bit of rainfall in this area, so people will be able to collect some water in a farm dam. So we might estimate around, on average, 2 megalitres a year per bore. So a very sort of rough estimate. In other regions, so for example, in the Surat, there are more complex analytical methods that are developed. And those estimation methods are based on, usually demand factors or supply factors. So things like the number of cattle, the quality of the pasture, what the bore yields might be. And yeah, so what we're seeing is that when you've got these smaller users, like stock and domestic, it's usually considered to be quite a small component of overall use. So if there is a bit of uncertainty in the estimates, it's only going to have a small effect on your modelling results because, overall, it's only a small component of the use. So just go to the next slide, Richard. So maybe just press another. Yeah, that's a bit of some funny animations going on. But yeah, in some regions though, what you would consider to be a small user ends up being quite a significant component of the overall use. And the Surat Cumulative Management Area is an example of that. So the brown dots in that middle figure show the stock and domestic bores in that region. And as you can see, there is a lot. There's more than 18,000. The yellow on the left figure, that shows that's your land use. So that the yellow is showing the grazing land. So in this region, as much as you might think, oh, well, these bores aren't taking much water, in actual fact, because there's so many of them, the Queensland government's estimated that it's about 20% of the overall groundwater use. So it is quite important to have a good handle on exactly how much these bores are taking. The graph on the right there is showing how the number of stock and domestic bores in this region has increased over time. So you can see in 1960, there was about 4,000 of these bores. But by 2020 and beyond 2020, we're getting up to 18,000 of these bores. So the number of bores going in is increasing all the time. All right, on to the next one. Okay, so the metering program was in the Surat Cumulative Management Area. So for those of you that don't know about this area, it's part of the Great Artesian, parts of the Surat Cumulative Management Area are part of the Great Artesian Basin, which you can see in the little map of Australia up the top there. Now, it's a multi-layered hydrogeological complex. So it's high permeability sandstones that are used to supply groundwater interbedded with these lower permeability mudstones and siltstones that act as aquitards. So coal seam gas is extracted from the coal formations in that system. And so just press the little down arrow there, Richard. Yeah, and so this, because it's part of the Great Artesian Basin, this area has some quite important spring ecosystems that are sourced from, these artesian aquifers. So I'll go to the next slide.
Where is that spring, Louisa? Do you know?
That is the Springshore, part of the Springshore complex. I'm not exactly sure. It's within the Surat CMA, I believe, but I'm not sure exactly where. Okay. But yeah, absolutely beautiful. So what we're seeing in the Surat CMA is that, all of these coal seam gas companies are operating there. And as I mentioned before, they need to extract groundwater to release the gas. And so the graph there on the left shows how the groundwater, what the groundwater demands are, or the groundwater extracted for coal seam gas are. And you can see around now is the peak, and then over time that groundwater will decline. And then the graph on the right is showing the different uses of groundwater in the Surat cumulative management area. So the petroleum and gas extraction is about a quarter of the total extraction. In the blue there is the licensed groundwater use, and so that is there's a lot of irrigators that use groundwater from the Condamine, the central Condamine alluvium, which is in the southeast of the area. And then you can see the stock and domestic use was estimated at about 25,000 megalitres. That has actually been re-estimated now to be a much larger share of the total extraction. The little one in pink there, so that is discharge from uncontrolled or free-flowing bores, and also losses from bore drains. So because the aquifers in this, some of the aquifers in this area are artesian, so that means they just flow without needing to pump the groundwater. Some of the bores are not capped properly, and so the water is just flowing continuously. And then some properties have open bore drains, so they are distributing water around their property just in these open drains. And as you can imagine, you're losing quite a lot of water through seepage, through evaporation. So there is a program at the moment. It's the GABSI program's actually been going for a very long time, and the most recent version of that program is working its way around all the landholders and getting people to cap their bores and also pipe their bore drains. Anyway, that was just a little aside. Let's get back on track. So we'll go to the next slide. Okay, so the Queensland Government have developed an underground water impact report for the Surat cumulative management area. And the objective of that report is to manage the impacts to groundwater systems associated with all of the groundwater that's being extracted for coal seam gas activities. So as part of assessing those impacts, they've developed a numerical groundwater flow model. And this diagram here shows, I guess, the architecture of that groundwater flow model, or the process for how that flow model's been developed. And you can see here that one of the many inputs into that groundwater flow model is stock and domestic use. So to estimate the stock and domestic use, so the stock and domestic bores are not metered. The Queensland Government's thinking, well, what volume are we putting into our model? They developed this analytical model, but because there was no metered extraction data, they had nothing to validate their model. And so that's when this bore metering program came into play. And so we'll go into the next.
Before we do,
slide.
so when you say no metered extraction, you're talking about the stock water, domestic.
Yeah.
There's plenty of metering on coal seam gas and the like, I'm assuming.
Yeah, so the coal seam gas wells are metered. A lot of the irrigation bores in the alluvial systems in the region are metered as well. But yeah, stock and domestic bores are not required to be metered, and some people might have meters on their bores, but they would not be reporting that data to the government.
You mentioned about mine pits being another user, effectively.
Yes.
Do they have to provide estimates of seepage coming into their pits, or?
Yeah, they do. So you can see where I've got that red circle, the dot point above that,
Oh, yeah.
existing mining pits. Yeah. So that's another take of groundwater that is estimated in the numerical model. So typically with mining, they at the environmental impact assessment step, so before the mine is approved, they will do their own groundwater model that will assess or predict what the groundwater inflows into their mine pits will be. And so, yeah, so government has a bit of a handle on what the dewatering volumes will be over the life of that mine. So that could be one source of data there. Mines also will typically prepare water accounts, site water accounts. So those water accounts look at all of the different sources of water and how water is managed on site. I don't think they're reported to government, though. It's not a requirement to report them. I think the coal mining industry is starting to report those to government, but other mines don't at the moment. So yeah, couple of sources of information for that one.
Just before we move on, so we had Greg Hoxley present. Greg's from Jacobs present on the increasing need for groundwater information as part of approvals for, getting new things going like mines, etc. You, in the case of the Surat Basin, my understanding was we developed the model before we really had a lot of a lot of monitoring data of the basin. Do you think in the future that will be a similar process? We'll develop a numerical model and then require more monitoring to confirm the model post approvals, or are we going to need more data pre-approvals? Is that a tricky question?
That is a really tricky question. I think the thing with numerical models, they're based on monitoring data and the conceptual model for the groundwater system that's developed from the monitoring data. And really that process should be one of continuous improvement. So I guess, really you shouldn't just be developing your model and then that's it. When you do your model for approvals, what will then happen is you'll then have requirements for ongoing monitoring. And generally, that data collected through that ongoing monitoring only will then feed back into your model if you're planning to do an extension to your project or some sort of amendment to the project design. So that's sort of what's happening at the moment, Richard. Yeah, it's I think only if you want to do an extension or change something. Yeah.
All right, back to you.
Back in. All right, let's get back to the book. So that's a bit of background about how the bore metering program came about. It was really to try and improve understanding of how much groundwater was being extracted from those 18,000 stock and domestic bores. Now, the program started in December 2015 and ended in June 2023, and it involved landholders across the area participating on a voluntary basis. So over the course of the program, 54 stock and domestic bores were metered on 40 properties, and some of them wanted to participate but on a confidential basis. And 13 properties agreed to full disclosure. So they're the ones that you can see on the map. And then the other 20 properties participated on a, how do I describe it? Like partial confidentiality, if that makes sense. So they're not shown on the map. So we'll go on to the next one. And I'll talk a bit about
confidentiality. That's a new one.
Yeah, I know. Yes. Well, we had to give it quite a few options. So this is what we're talking about here. So these properties are pumping groundwater into these troughs that you can see here on the right, and then the cattle are drinking from those troughs. So there's a whole different range of cattle breeds out in the Surat. On the right there, that's an Asian breed. So they're quite drought tolerant because, you know, in Asia it's quite hot. So those cattle, we found actually that those cattle were drinking less. And then on the left there, we've got a crossbreed. So that's a cross between a European cattle breed and an Asian breed. Okay, we'll go on to the next one. Okay, so in terms of recruiting participants, it was quite a long process and quite tricky. So the government couldn't just tell us, oh, here, you know, here's the names and phone numbers of people with stock and domestic bores. The government can't just hand over people's information. So we had to figure out how we could try and get in touch with people and find people that wanted to volunteer. So most of our participants came through referral. So we knew a hydrogeologist that worked in the region. We knew a driller that worked in the region. And we also knew some community members that were quite interested in water management. And so they were able to refer people to us that would be interested in volunteering. We tried doing a letter drop, so sending letters out, and that was not a successful method. We actually didn't recruit anyone through that process. So I'd say we went in the bin with the rest of the junk mail. One method that was pretty successful was cold calling. So going to the government database of all the stock and domestic bores, figuring out what properties those bores were on, then, you know, searching through the internet, looking for who might own that property, and then trying to get phone numbers for them. So it's quite an arduous process, but we ended up getting quite a lot of people that way, and a few through word of mouth and meetings. This form on the right here is a consent form. So any project, you know, that involve people, you know, this whole ethics process that you have to go through to get approval to do the project. And then a lot of people were raising concerns about who was going to see how much water they were taking. You know, they're worried that their neighbour might see how much water they're taking, or the government might see. And so what we did was we set up the option that people could participate in the program on a confidential basis. So that's what that form there is. And here we can see that there's options down the bottom: restricted disclosure or full disclosure were the options. And then some people were also like full confidentiality as well. So the restricted disclosure meant that we could see all the data, and the Office of Groundwater Impact Assessment could see all the data. Full disclosure is that anyone can have access to the data. All right, on to the next one. Yeah, so one of the challenges was selecting a representative subset of bores. So if you've got 18,000 stock and domestic bores, how do we know if the ones we're metering are representative of those 18,000? And so we tried to think about, you know, what are the different things that we might want to consider. So spatial coverage was one of them. The source aquifer for the bore, and you can see on the right here, this is, you know, a bit of the stratigraphy of the Surat Cumulative Management Area. The blue layers are the aquifers, and the green ticks are the bores which layers we were able to meter bores from. So you can see we do have quite good representation from the different aquifers. We also thought about metering some artesian bores and some sub-artesian bores, bores that were used for stock compared with bores used for stock and domestic. We also thought about the type of cattle operation. So some of these properties are breeding cattle at the property, but others are just backgrounding. So they're buying young cattle and fattening them up. So we tried to get a bit of a mix of properties that way, and then also the size of the property and the size of the business. So the cold calling process allowed us to kind of fill in the gaps that we had with the other volunteers. Okay, another process we had to go through was selecting the equipment. So there's all different sorts of meters. There's electromagnetic meters, mechanical meters. The type of meter that we ended up choosing was an ultrasonic meter. Now, the reason we chose these was because they do have quite a number of benefits. So one of them is that they're non-invasive. So you don't actually have to install the meter into the bore pipe, into the bore itself, or into the bore pipework. They can just be attached to the outside of the distribution pipe. And you can see there in the red circle, the little transducers, which are just clamped onto the outside of the pipe. So they're almost like portable, I suppose. You can put them on and then you can move them to a different bore if you want. So that was one of the pros. Also, you can use them on a range of different pipes, so different pipe diameters, different pipe materials, and also you can use them to record quite high resolution time series. Some of the cons is that they're quite sensitive to your pipework configuration. So you really need like quite a long length of pipe to attach them to, because if you're getting turbulence or any cavitation in the pipe, the readings that you're getting on your sensors are just going to be no good because they're affected, by that turbulence. These types of meters are also sensitive to fluid properties. So you can see here we've got them clamped onto the side of the pipe. So the groundwater in this area, some of it's got quite a lot of gas in it. And you can get the gas bubbles at the top of your pipe. So that's why we put the sensors on the side there, just to try and remove the effects of the gas. And then the readings you're getting from these meters are also sensitive to the sensor alignment. So you can see there the sensors are in a straight line and a certain distance from one another. If those sensors get knocked, so let's say some of your cattle come into the area, step on the sensors, your landholder might step on your sensors, you might have a inquisitive bird messing around. If those sensors get knocked out of alignment, you're getting really unreliable readings. So there's some of the problems with these meters. All right, we'll keep going, Richard. So this is just to give you a look at what some of the data looks like. So this is data from a diesel bore that was manually operated. So the landholder would drive out there, fill up his diesel tank. You can see the tank there in the photo, and then turn the bore on. And so what you see with this data, you can see these pumping sequences. So they might pump for several days at a time. He might even go and fill up the diesel in between. So we'll go on to the next one. And then this bore here, you can see that the pumping signature looks quite different. So this bore here is on a float. So there's a float inside the water tank. So the bore pumps to the tank, and then the tank pumps to the troughs. So the float is in the tank, and when the water level gets below a certain level, the bore pump will switch on. So you can see here that pretty much every day the bore was pumping into that water tank. So this just shows that there was quite an intensive data cleansing process that I had to go through. So unfortunately, the data from the meters wasn't just perfect when I got it. There's often some problems with it. So if the transducers had been knocked, things like that. So I had to go through this data cleansing process. You can see on the right here, You know, I've got quite a nice pumping sequence going on there. So these are average hourly pumping rates there. So we'll go on to the next one. Okay, so these are the results. So what we've got here is annual groundwater extraction by bore. So what you can see, so on average, the extraction was 5.8 megalitres a year. But, you know, it ranged from bore to bore, and you can see this huge variation between bores. So if you were going to go with an estimation method where you said, well, you know, maybe it's 5 megalitres per bore, 5.8 megalitres per bore, that might be okay for the numerical model that you're developing. But if you've got a numerical model like the one that Ogia developed, where they're trying to understand year-to-year variation, you might actually want to have a bit more of an understanding of how the extraction is varying from bore to bore. And so this raises the question, well, why are we seeing such differences in extraction at the different bores? And is there a way that we can predict what the extraction is going to be from individual bores? You know, what are the different factors that might be able to predict those differences? So we go on to the next one. So we collected data through landholder interviews as well. So I did 4 rounds of interviews with the landholders, and I tried to do them face to face where I could, but where I couldn't find the landholder, you know, they tend to be very busy. I'd try and catch them on the phone. So I used survey sheets and maps and collected data on a range of different things that we thought could be influencing the groundwater extraction. So we go on to the next slide. These are all the different things that we collected data on. Lots of different possibilities for what might be influencing the extraction. So we go on to the next one. One of the main things that I collected data on was cattle numbers, because, you know, you've got this many cattle, you've got lots of cattle, they're going to drink more groundwater than if you've only got a few cattle. So we knew the cattle number was going to be one of the key factors. Now this is a screenshot, sorry, go back. That's a screenshot of a model that was developed by McLean and Blakely. And the purpose of that model is to standardize cattle numbers into what they call adult equivalent. So you can imagine if you've got a backgrounding property that has a lot of young cattle, so they might have 50 young cattle, and then another property has 50 cows that are breeding. They're not really equivalent because they're completely different weights. You know, they're going to drink completely different amounts of groundwater. So the idea with this model is to standardize your cattle numbers so that they can be compared. So I use that model to standardize cattle numbers.
Just a quick question. So with our shallow, I guess, water table aquifers, do you take into account, you know, evapotranspiration rates from native forests and things like that?
I didn't, for this study, it looked only at subartesian or artesian aquifers. So it only looked at the deeper aquifers. So the study I didn't look at the alluvial systems. So no, I did not account for that in the modelling that I did, no.
No worries.
Okay, so here's a bit of a messy looking equation that looks at all the different factors that could be affecting your groundwater extraction. So consumption by livestock is the obvious one, but then also consumption for domestic purposes, garden, consumption by native and feral animals. I don't know if you guys have seen those. There's some amazing videos. I think the company's called Emu Logic, and they've got these videos. They've put little cameras on the end of the troughs, and you can see all the native and feral animals coming to the troughs and drinking water. So that was one of the things we thought, oh, that could be affecting how much groundwater you have to pump. And then evaporative and seepage losses from your water storages as well. So a lot of these bores are pumping into big open turkeys' nests, so you're going to get those evaporative losses. Leaks from your distribution pipework could be another factor. And then operational losses as well. So it's quite interesting. There was a few situations where dams were just overflowing because something had malfunctioned on the bore pump timer, and the bore was just pumping and pumping and pumping. So you can get, I guess, user error things happening as well. So lots of different things that could potentially affect how much groundwater. So if you just press the down arrow, Richard. So initially, I looked at all of the interview data and did some statistical testing to say, well, based on all the interviews, all of these different things that the landholders said were going on, let's have a look and see which of those different things could be affecting the volume of groundwater being extracted. And these are the things that came up. So cattle numbers, and I've also highlighted cattle breed there as well, because those two things went towards those standardized cattle numbers. Climate came out as statistically significant. The purpose of the bore came out as significant. So bores that were used for stock and domestic used more groundwater than bores just used for stock, which is what you'd expect. Aquifer pressure came out. So whether the bore was artesian or subartesian came out as being important. And then also the water storage infrastructure. So where a bore was pumped into an enclosed tank, that bore overall used less water than a bore that pumped into an open turkey's nest. And I'm guessing that's to do with the evaporation and the seepage losses. All right, so we'll go on to the next one. Okay, so then I guess that raised the question, well, can this cattle number data and the metered extraction data for this representative subset of bores, can that data be used to predict groundwater extraction at the unmetered bores? And what public domain data sets can be used to predict those things? So, we're not going to go and do interviews at every property. So what, data that's out in the public domain, things we can just download from government websites, what of those data sets can we use to predict extraction? So I started off by trying to predict cattle numbers because we know cattle numbers are so important for predicting groundwater extraction. So this is all the cattle number data that I collected through the interviews. And you can see, if you press the down arrow, Richard, you can see in the 2018, 2019, 2020 water years, you can see this sort of trend towards destocking on these properties. And so this is when there was a really widespread drought in that region. And yeah, so you can see that trend there. So these are the cattle number data that I trained my model with. So we'll go on to the next slide. And so these are some of the public domain data sets that I used for the model selection process. So I thought, okay, what are all the different public domain data sets that could predict cattle numbers? So grazing area was an obvious one, or that grazing area or property area, so the size of the property, I thought would be important. And then the different climatic parameters and also pasture parameters, because the climate is affecting the quality of your pasture. If you've got a very dry climate, your pasture is not going to be as good as if you've got, much more rainfall. So climate was important. There's different indicators of pasture that you can get from different remote sensing data and also different models of pasture. The ground cover data is from remote sensing data, so that's quite a good data set. And then I also looked at things like commodity prices. So how, was the price of fodder. So let's say your pasture's terrible. You need to buy hay in to feed your cattle. If the hay price is just way too expensive, are you going to you're going to get rid of some cattle? You're going to sell your cattle. You're going to destock. And then also looked at the Eastern Young Cattle Indicator. So did the price of cattle affect the number of cattle that people had on their property? So if you press the down arrow, so with some of these parameters, I looked at both the current year and also the previous year, because what came out of the interviews was that, often there's a lag in adjusting cattle numbers. So let's say you had a really dry year, the next year your pasture is not going to be much good, and so you're going to try and sell off some of your cattle. But it's not always, just an instantaneous process to sell your cattle. Sometimes it takes a little bit longer. All right, we'll go on to the next one. Try and move on to the groundwater extraction bit. So this is the cattle number modelling approach. So I used the R statistical software and modelled cattle numbers using a generalised linear model. So in this case, we'll just keep skipping. This is the process. If anyone's interested, you can have a bit more of a look at that later.
You've got about 5 minutes left.
Okay. Oh, I'm nearly done. Okay, so then this is the results of the model. So the model was able to explain about 74% of the variance in cattle numbers from year to year. And the most important parameter there was actually improved pasture. So that's where people are going in and sowing other types of pasture on their property to try and improve the quality of the pasture. So that was the most important variable. All right, we'll move on to the next one. So then I took the outputs from that model. Here's the data. So this shows you the cattle number interview data against the modelled data. So you can see for the smaller properties with the smaller cattle numbers, the model performed quite well. But on those larger properties, and particularly backgrounding properties, so the properties where they're buying and selling cattle all the time, it's much harder to predict the cattle numbers. You can see much bigger residuals on those larger properties. All right.
Do you know that DPI New South Wales have a model, and they've used the sort of long-term climate forecast, and I think it's for the whole of New South Wales, they have a biomass index that they've calculated it might even be a daily time step, just worth people being aware of. That's one of those variables.
Okay, so now we get onto the groundwater extraction data. So this is the data that I used to train the model. So you can see we had 6 years of data. And again, if you press the down arrow, Richard, you can see in that drought period, you can see that the groundwater extraction was, a bit higher than in other years on average. So this is what I used to train the model. These are the different public domain data sets that I looked at using to predict groundwater extraction. So I thought, okay, what are the parameters that indicate what the bore is being used for? So is the bore being used in the house? Is it being used for weed spraying on cultivation areas? Is it being used for coal seam gas dust suppression? Also had a look at parameters that might influence how much water the cattle are drinking. So the air temperature, if it's hot, the cattle are probably going to drink more. Pasture quality is another parameter that can influence how much cattle drink. And then also looked at the availability of other water sources. Were there any sort of permanent streams on the property that people might use in preference to using groundwater? And then a couple of other parameters as well. So we'll keep going. Skip through. This is the modelling approach, similar to the cattle model, used at GLM. And then these are the results. So the model selected 9 out of the 12 parameters Number of cattle was the most important parameter, which is exactly what we would expect. Some of the coefficients were negative, which is what we would expect. So where the property had a perennial stream, they used less groundwater. So that makes sense because you'd use surface water in preference to groundwater. And again, properties where they had more rainfall, they used less groundwater, which also makes sense. All right, so I'll skip on to the next one. Yeah, so this, as with any model, there's limitations. So the groundwater extraction model could only explain 51% of the variation in annual groundwater extraction. And that remaining variation that couldn't be predicted, there's lots of different reasons why the model couldn't predict with 100% certainty. So, for example, there could be variables that there was no public domain data for. So things like the type of water infrastructure that they were pumping into. Or things like, the farmer's attitude to water efficiency. So some farmers were very conscious of preserving water and other farmers were, a little bit more relaxed about it. So that could influence how much water is being pumped. If the public domain data sets are not representative of the actual conditions. And then also measurement error. So these meters that we use, they're not 100% accurate. I had to post-process the data and I made decisions when I post-processed the data. So there's going to be error, inherent error in those processes. And then some of the input variables were actually modelled variables. So the cattle number model was one of those, and also root zone soil moisture was another modelled input variable. So yeah, lots of ways. And there's the results. So that is the metered extraction data against the modelled data. And so you can see again that, we're getting, quite a lot of, the residuals are getting bigger as the volumes being extracted are getting bigger. So on those bigger properties, there's more uncertainty. All right, flip to the next one.
How does the uncertainty of this exercise compare with the uncertainties associated with like mine site seepage, etc.?
I would say they will be comparable. It depends on, it depends. It will depend model to model. So, and that comes back to a bit of a plug for you, Richard. Models that are developed with, with more monitoring data, we'll be able to predict more accurately in general. Not always the case because there are, say, for example, if a system has the conceptualization has missed a critical factor, then it's not going to be able to predict very well. So this would be comparable with some of those groundwater flow models that are developed in terms of the uncertainty. The other thing with groundwater flow models for approvals is, there's often not a process where they go back and check, 10 years after building the mine, how accurate was that model that we submitted for approvals? So it's hard to know in some cases, Richard.
That's kind of interesting looking at some of the factors that affect it. I mean, they're all variables in themselves, right? They can change.
That's exactly right. Yeah. And yeah, so this compared the statistical model that I developed, which is the one on the left, with a couple of other models that were developed. So the model on the right there is an analytical model that was developed by the Queensland government probably five years ago. They have actually developed a new analytical model now, but I haven't had a chance to compare to that yet. The model in the middle is another statistical model that was developed by a colleague of mine, But that model was developed after only 6 months of metering. So you can see that after 6 years of metering, which is the model on the left, that we were able to improve the model. So that longer period of record improved the ability for the model to predict what the extraction would be. So yeah, that gives you a bit of an idea of just comparison with other models.
Did yours the best?
Yeah, of course.
Well,
But, we say, oh, it's the best, but at the same time, it could only predict, 51% of that variation. So it's still not fantastic. So I guess in terms of the contributions to knowledge, so this program improved the knowledge about groundwater extraction rates for cattle grazing. And we also learnt a lot about implementing these voluntary metering programs. And I wrote a paper about some of the challenges of these voluntary programs. They are quite hard to implement. And then also learnt a lot about some of the factors that are driving this variation in how much groundwater is being used. And then, I guess the program also demonstrated that, these types of voluntary metering programs where you're metering just a subset of bores can be really useful to predict extraction, unmetered extraction at other bores.
I think that's a really important contribution. We often have monitoring programs with, hundreds and hundreds of monitoring wells, but a subset's probably sufficient for managing sites and the like. So it's interesting your approach you've put to that.
So there were a number of limitations with the study. So as much as the approach could be applied to other regions, the actual models that were developed and the data that we collected might not be able to just directly apply those to other regions. And that's because, the model that we developed was specific to that region in terms of, the climate of that region, the pasture in that region, what the water availability is like. So in other regions, there might be other factors that are important for influencing groundwater extraction, and the relationships might be different. Another limitation of the study is that data confidentiality piece. So we saw that quite a lot of the participants opted for partial disclosure. And so that is where only UQ and OGIA can access the data. So all of this fabulous data were collected, but not anybody can't just get access to that data, unfortunately. And then, of course, there were some limitations with the data quality. So the metered extraction data, there were some data gaps where the meters failed, or where, we had some birds chew through some electrical wires, and, a few different things happen. We had a meter that got flooded because the landholder decided to build a dam right where the meter was. So we had a few interesting things happen. And then, in terms of the interview data that we collected, some landholders were really open to the interview process, but others were, a little bit more wary. And so the data that we collected from them, wasn't quite as detailed and as good. So I'll move on to the next one. So just in conclusion, there's lots of different scenarios where voluntary metering of extraction would be beneficial. And, there'd be programs like this could be really useful where you're trying to manage a groundwater resource, or you're doing an impact assessment and you need to get a handle on, some of these unmetered groundwater users. This approach could be applied across a range of hydrological environments. So not just groundwater, it could also be applied to surface water systems as well. And also across a range of agricultural settings as well. So you could use a similar approach, voluntary metering of irrigation bores if you're in an area where there's no metering going on. And just the study demonstrates that this empirical modelling using these public domain data sets can be a really effective means of estimating unmetered extractions. So I think I've got a couple more. I can't remember what I've got next. Oh yeah, just some final reflections. The metering program wasn't a trivial exercise. It involved a lot of people over many, many years. And yeah, interestingly, the program ended on the 30th of June 2023, and we offered some of the landholders the options of retaining the meters, and 14 of them have actually opted to retain them. So they really liked being able to see how much water was being pumped from their bore. They found that really useful, and they wanted to keep the meters. And then the other meters were decommissioned, and we've still got, I think, 6 of the meters at UQ. If anyone ever needs to have some use for them. So it's a great example of collaboration between industry, government, the university, and also the community. Like all of the landholders that participated, they gave so much of their time. They loved being involved in the program, a lot of them. And yeah, just all the energy and they gave to the interviews and everything are much appreciated. And yeah, just a huge thank you to my supervisors and also all the program funders, which included Ogia and all the gas companies. So I think I've just got a couple of a screenshot of a couple of papers that were written from the program, and there's another paper coming as well that'll be out. The next paper will talk about all the statistical modelling.
Very good. Well, thanks, Louisa. Now we're going to move to Q&A, and thanks for everyone who's still here. Really appreciate it. First, we'll do the early bird questions. Is there any data on the use of bores registered for stock and domestic use in urban areas, or are they a legacy of previous land?
Yeah, that is a really good question. So the data that are available for well, I guess in urban areas, they're typically domestic bores. So, there's, people using bores for their veggie gardens. That's a pretty common one in urban areas. Or using bores to water their gardens. So some of those bores in urban areas will be registered with the state government, but it just depends on when those bores were drilled and what the requirements for notifying the government about drilling those bores was at the time they were installed. So that in every state government, you'll see there's periods of time where people were not required to put in a works approval or notify the government about bores. So people could just put bores in and they didn't have to tell the government. So they will not have records of those ones. And there's also instances where people even now will put bores in and won't notify the government. So yeah, there's definitely a bit of uncertainty the location of bores and how many there are. Yeah.
Okay. Next one. Thanks for your work, Louisa. So thank you. How does stock and domestic use compare with water lost in free-flowing bores and irrigation?
Yeah, that's a really good question. So I think I had that diagram where I showed that there's still water being lost out of the Surat cumulative management area in free-flowing bores and in open bore drains. And there's this federally funded program. I think it's called it used to be called the Great Artesian Basin Sustainability Initiative, GABSI. But now it's called the Great Artesian Basin Restoration Program, I think it's called. And so what it is that the Commonwealth government is um, partially funding these free flowing bores to be capped and the bore drains to be piped, just to stop this continuous loss of groundwater, and to restore pressures back to those artesian aquifers. So that's an ongoing program. I know in Queensland, the latest version of the Great Artesian Basin Water Plan required that landholders notify if they had a free-flowing bore and develop a plan to have that bore capped and piped. So there's been, great progress in capping and piping those bores over the last 20 years, I would say. There's been amazing progress, but there are still some that haven't been completed. But yeah, it's getting close. And then in terms of irrigation, so irrigation users are typically much bigger users than stock and domestic. And, their license volumes, like 100 megalitres a year, that type of thing. Whereas, as we saw with stock and domestic, on average, they're using about 5.8 megalitres a year. So irrigation users are often much bigger users, and they're typically licensed and metered. But again, it depends where you are located and where the state government is up to with regulation. The state government is, constantly looking at what are our biggest risk areas, where are we seeing groundwater levels drop, and therefore we need to get in there and manage that resource. So it's an ongoing process.
All right, next question. Model inputs, data sources, address uncertainty, model confidence. What justified a change if proposed?
So the lovely thing with a PhD is that you can sort of do whatever you want, and you've got time to do it. So in this instance, the Queensland government, so OGIA, had an analytical model to predict stock and domestic use, and the bore metering program was undertaken to validate that existing analytical model. And what the government found was when we collected the metered extraction data, we sent it through to them, that analytical model was actually working really, really quite nicely. And I showed that graph with the model errors. They have further refined that model, and I'd say that that analytical model is performing even better than the older one. So I don't think it was that we necessarily needed to develop a new model or needed to reduce the uncertainty in the existing model. That sort of wasn't what was driving the statistical model that I developed. I've probably more developed that, I guess, as a researcher and thinking about, okay, we have this analytical model that OGIA has developed. What could be an alternative approach, and can it predict as well as that analytical model? So yeah, that was probably more what was driving the research. And then in terms of the model inputs, I think I talked a little bit about that in the presentation. So yeah, using public domain data and then selecting that based on, literature searches about what are the important things affecting groundwater extraction, and also the interviews informing, what the important factors might be.
Okay, I'm going to move on to the Q&A questions. You happy to keep going for a bit, Louisa?
Yeah, if people are still here, they haven't fallen asleep yet.
We've got about 70 people asleep at their desks, but no, just joking. Are there PFAS limits and guidelines in groundwater?
I don't actually know that. So I've
We'll take that one on notice.
Yeah, I'll take that one on notice. I mean, I'd say there probably needs to be. I have worked on a project that had an issue with PFAS in the groundwater, and it was, moving towards a town water supply. Um, but yeah, I'm not across that at the
All
moment.
right. Um, we'll take that one on notice. Off to a bad start.
After a
Next
bad start.
one. What criteria were adopted to select the representative subset of 54 bores?
Yeah, so I think I had a slide on that. There were a few different considerations. So one of those was good spatial representation. So you can imagine that is a 200,000 square kilometre area. So it's a huge area. And so the climate is going to vary quite a lot across that area. So spatial representation was important. And then source aquifer representation was important. So we wanted to make sure we weren't just metering bores that were all out of the one aquifer. We wanted to get some representation there. Property size, type of cattle operation. So that was whether the property was breeding cattle or whether they were backgrounding cattle. So yeah, there was quite a number of different factors that we tried to cover. So we had quite a lot of people volunteer, but we didn't meter all of their bores. Actually, one of the important factors was whether the setup of their bore was suitable for those meters that we selected. So some people we thought, oh, this is a great bore. This is going to be a great property location, property size, type of, that's really nice to get this representative subset. But then we got there and the configuration of the bore just really wasn't suitable for the meter. Sometimes the landholders actually reconfigured their bore for us to put the meter on. But sometimes that just wasn't an option. So yeah, so that was an important factor as well, was the bore configuration.
Okay. A note from Anne Gibson saying groundwater was included in the Murray-Darling Basin Plan. So
Yes,
that's
I
good. I
was
think.
involved in that.
So did that include having those numerical models that would underpin that? Is there a numerical model for the Murray-Darling Basin groundwater?
So in the Murray-Darling Basin, there's a lot of different groundwater systems. So it's not just one groundwater system across that region. So for example, in New South Wales, there's a number of alluvial groundwater systems. You've got, the Sydney Basin groundwater in Queensland. You've got the Central Condamine alluvium groundwater system. So there's multiple different groundwater systems in the Murray-Darling Basin, and my understanding is that the Murray-Darling Basin Plan relies on the state models for those systems where they exist. So not every groundwater system will have a numerical model. It would just depend on whether, what the risks are in that groundwater system and whether a numerical model is going to help the government manage that system. So yeah, so there'd be multiple models
Right.
led by the states.
Okay. And then somehow they get a combined for the Murray-Darling Basin Plan.
Yeah, so the Murray-Darling Basin Plan will have sustainable diversion limits that are set for each of those groundwater systems. And so those limits are set, it's essentially a negotiation between the states and the Commonwealth around what those limits are going to be and what the rules for managing water are going to be in that system. So that, I don't know if that's changed since I worked on the plan, but that's essentially how it worked when I was involved. Yeah,
Good question, that one, Anne. Thank you.
yeah, really good one.
Walter Wenig, has anybody done a post audit to see how the initial models have performed against data collected after the model was developed? That would be an interesting project for research.
Yeah, absolutely. The funding for the project finished. Um, the way that I looked at model error was using a leave one out cross validation. There's other ways that you can look at that. So I could, you can split the data into training and test splits. And so one way you could do that is, I could train the model on, say, 4 years of data, and then see how the model predicts for 2 years, another 2 years of data, and then assess, how well your model is predicting. So I could have done that. I didn't do that, but that is one option. Because there was only 6 years of data, if you think about the range of, say, climatic conditions that you're getting, 6 years is not going to capture, the full range of conditions that you might expect. So yeah, I was a little bit constrained with how much data I had to work with. If you were monitoring over a much longer period, then definitely, seeing how well your model is predicting into the future would be a great way to understand how well your model is performing.
Okay, there you go, Walter. Paul Webb, did you use Queensland government forage products to inform the grazing pressure values?
Yeah, so I've worked with the guys at Queensland Government that have developed the forage model. So the forage model it was developed to help landholders with figuring out how many cattle their land can support over the long term. So different properties are going to be able to support a different number of cattle. If you're in a region where you've got, quite a bit of rainfall, you've got nice warm temperatures, your pasture's growing really well, your property is going to be able to support a lot more cattle than a property that's in a very dry area, and your pasture is just not growing very well. So the purpose of that forage model is to give advice to farmers about how many cattle they should be putting on their property. And the idea is that they're sustainably managing the land. So they're not overstocking the property, destroying the pasture, and then they've got to destock. So the idea is more sustainable land management. So I had a look at, well, could the outputs from forage be used to predict cattle numbers? And so I did a comparison between what forage is telling farmers that they should stock and what they are actually stocking. And it was actually quite different. And so that's why I didn't use forage in my modelling. And I guess it does make sense because, forage is sort of like an idealistic cattle number, but that's not necessarily how people are managing their properties. So, yeah.
So Paul goes on to say, e.g., forage have good sustainable stocking rate numbers and combined with ground cover indicators for land
Yes. Yeah.
condition could be weighted to estimate actual. So you found, so that's not a bad way to sort of estimate stocking rates.
Mm,
People are saying, well, if farmers are doing it in a good sustainable way, yes, but otherwise,
yeah.
no. Okay.
Yeah.
Paul thanks you for your great work. Um, so yes, good work, Louisa.
Thank you.
Next one, Eamon Lay. To what extent do you think your model could be extrapolated beyond the Surat CMA, or would any other study area require more volunteers for metering?
Mm. I think it would be applicable to other parts of the Great Artesian Basin, I would say. So, similar sort of climate, similar types of cattle operations, I'd say you probably could apply it more broadly across the GAB. But yeah, and look, you could try and apply it in other areas and perhaps just meter a subset of bores and even test it with the data from those meters to see whether you think it could be applicable. Yeah, I would say just because, you know, there are differences climatically and, you know, with pasture quality, even property size, that the data we use to train the model might not be applicable. So the model might not be applicable in other regions. But yeah, I think, yeah, probably GAB, areas with a similar climate and similar type of land use, then yeah, maybe it would work.
Interesting. Meat and Livestock Australia, I think they're called. They engaged a
Yeah,
company called Cyber Labs to do satellite-based biomass measurements across the whole of Australia
yeah,
um,
fabulous.
for pasture. Do you think you could use that?
Is that the total standing dry matter?
Not sure. I'd
Yeah,
have to.
there's so many different indicators for pasture. There's lots of different ones, and I in the model selection process for predicting cattle number, I put quite a few in to see which one the model would select. And interestingly, it selected ground cover and also ground cover in the previous year as well. And so that's remote sensing data from one of the satellites. So yeah, but yeah, there is lots of different indicators of pasture. So I got the model to choose which one was working the best for prediction. Yeah.
Makes sense. Paul Webb's put in an abbreviation, Gabora, Gabora. I'm not sure the
Yes.
context. Do you know what that stands for?
It stands for the Great Artesian Basin and other regional aquifers, I think.
Ah,
Um, it's the name of the water plan that's got the GAB in it in Queensland. Yeah.
right.
Yeah.
Okay. And he's gone on to say, I don't think the GAB water was included in the Murray-Darling Basin plan, only the
No,
alluvial.
that's right. Yeah, not the GAB.
Thanks for those, Paul. Last question. You've done very well. Um, did the GAB formation extracted from impact how much water was taken? Also, was there a difference between artesian and sub-artesian?
Yeah. So the first question, can I get you to repeat the first part of the question, Richard? I'm not sure I
Sure. Did the
understood that.
Great Artesian Basin formation extracted from impact how much water was taken?
Oh, that is a really good question. I did not look at that. Um, the reason being, you probably remember that slide where I showed the stratigraphy of the Surat CMA, and there's all the different aquifers and aquitards. And then I had the green ticks showing which formations we monitored from. So because we only had 54 bores metered and so many different formations that groundwater was extracted from, yeah, we ended up with only one or two bores being needed from each formation. And if you know the geology and the hydrogeology of that part of the world, the aquifer that the landholders are extracting water from varies spatially because of how the formations are dipping and which which aquifer is shallowest in each location. So the answer to that one is that no, I didn't look at that, and the reason was because I didn't have enough data for each formation. And then the second part of the question, was there a difference for sub-artesian bores and artesian bores? And the answer to that is yes. So that was one of the predictors that the model selected. So the model told us there was a difference in groundwater extraction for that artesian bores. There was more extraction than for sub-artesian bores. And so, I mean, my sort of thoughts on that was, well, it's free to pump from an artesian bore, so maybe that was driving the behaviour. Whereas when you've got to actually pay for the energy to pump the bore, you might be a little bit more conscious of how much water you're pumping. So that could be one of the factors driving that. I'm not sure. Yeah.
Right.
But it did come out as important. So that was a good one.
So thanks very much for presenting today. That was fantastic, and congratulations on this comprehensive piece of work. So yeah, many thanks, and that's it for today.
Thanks, Richard.
Thank you very much. Thanks, everybody. Bye for now.